As to this question here, the question is under redox, the topic in secondary to chemistry called redox. Now, what the question reads? The question says the reduction half equation of this equation below is dash. They ask to write the reduction half equation of this reaction, and this question is coming from WAEC 2023, right? Chemistry, objective question. Now, what is the equation? The equation is zinc reacting with copper sulfate, right, produces zinc sulfate and copper metal. We are asked to write the reduction half equation. Now, the equation might sound strange. When you hear reduction, you should also be talking about oxidation, right? So it is called redox, reduction and oxidation. Now, what does reduction and oxidation mean? Before we start looking at the half redox or the half reduction equation of that particular reaction. What do we mean by reduction? And also, what do we mean by oxidation? Reduction and oxidation can be defined in three different terms. In terms of hydrogen and oxygen, that's number one. In terms of electron transfer, that's number two. And in terms of oxidation number. Now, let me define it clearly, and then we are going to use either of them to adopt in order to tell which of this metal is reducing or which of the metal is oxidizing. Now, the first definition of redox, reduction and oxidation is defined in terms of hydrogen and oxygen. Now, we define oxidation as the addition of oxygen or the removal of hydrogen. What about reduction? In terms of hydrogen and oxygen, we define reduction as the removal of oxygen or the addition of hydrogen. That's number one definition. And the second definition is in terms of electron transfer. And in terms of electron transfer, oxidation can be defined as the loss of electron, while reduction is defined as the gain of electron. So when electron is lost from a substance, it is called oxidation. But when electron is gained into a substance, it's called reduction. And lastly, redox can be defined in terms of oxidation number. When we have a substance that increases its oxidation number, we call that oxidation. But when a substance or a metal reduces its oxidation number, it is called reduction, right? So in these three terms, redox can be defined in terms of hydrogen and oxygen, in terms of electron, and in terms of oxidation number. Now, we are going to use just one of them to define this particular equation. Remember, the equation says that we should write the half reduction equation of that reaction. So we have to know which of this metal, zinc and copper, is reducing or which of them is oxidizing. Now, firstly, we cannot use hydrogen and oxygen to define this because we don't have any oxygen, any hydrogen here. Even the oxygen we have here is not directly bonded to the metal. So we can't define that equation in terms of hydrogen and oxygen. Also, we can't directly define this equation in terms of electron transfer because the charges are not visible here. So it's very difficult in order to define this equation in terms of electron transfer. But we can define this in terms of oxidation number, and which that is the best way of analyzing a redox half equation, right? A redox half equation is best analyzed by oxidation numbers. Now, let's move further. What is oxidation number of zinc here? Remember the rules in oxidation number. When an element is alone without combining with any other element, a neutral element, its oxidation number is what? Is zero. Remember that. So the oxidation number of zinc here is zero, and that of copper here is also zero. Now, what about oxidation number of copper here and oxidation number of zinc here? Remember that this particular radical, SO4 2 minus, the oxidation number of everybody here is -2. So definitely if copper will be combining with SO4, its oxidation number, its charge is going to be +2. So its oxidation number is +2. And this particular SO4 oxidation number is -2. Same with zinc. Oxidation number of zinc here is +2 because the oxidation number of SO4 here is -2, right? Using our scissors method of writing. So this is going to be CuSO4, right? So copper here is +2. Zinc here is also +2. Hope you got that. So oxidation number of zinc here is 0. zinc here is +2, oxidation number of copper here is +2, and copper here is 0. Now let's use oxidation number to define that. Remember what I said. I said in terms of oxidation number, oxidation is the increase of oxidation number and the reduction is the decrease of oxidation number. Now let's analyze this element here, zinc. This is the reactant side and this is the product side, right? Now from oxidation number 0 to oxidation number +2, is zinc increasing in oxidation number or is reducing? From 0 to +2, definitely zinc is increasing the oxidation number. And we say increase in oxidation number is called oxidation. Why copper here? From +2 to 0, from +2 to 0, you find out that the oxidation number is reducing, right? So the oxidation number, the from +2 to 0, this equation is known as the reduction equation. So in summary, there, our question says that we should write the reduction half equation. The reduction. So we've known that copper here is reducing. So the half equation is going to be copper sulfate giving us copper, because we know that copper here, the oxidation number is +2, and copper here, the oxidation number is 0. So this is our reduction half. What if we are asked to write the oxidation half? Very easy. We've known that zinc here is oxidizing, right? Or is undergoing oxidation. So zinc here plus giving us zinc sulfate. So from oxidation number 0 to oxidation number +2, we have our oxidation half equation. Hope you learned something today. If you do enjoy this video, make sure you give it a like, subscribe to this page, and have a nice day. Thank you.